Hey everyone, welcome back to our channel Game Developer Unity. In today's video, we'll be diving deep into one of the most important topics in Unity, the difference between update, late update, and fixed update. These are essential methods you'll use in almost every Unity game, but understanding when and how to use them correctly can be a bit tricky for beginners. So, let's break it down and make it as simple as possible. Introduction to update, late update, and fixed update. In Unity, the game loop runs continuously, updating the game world at regular intervals. However, Unity gives us three different methods to handle updates: update, late update, and fixed update, each with a unique purpose. Knowing when and why to use them will make your game smoother and more predictable. Here's the basic breakdown of each method. Update, called once per frame. Late update, called after all update methods have finished. Fixed update, called at fixed time intervals, independent of the frame rate. Update function. First up, let's talk about update. This method is called once per frame, meaning it runs as fast as your frame rate. If your game is running at 60 frames per second, update will run 60 times every second. It's ideal for tasks that depend on the frame rate, like moving characters, handling input, or updating animations. For example, here's a script that moves a cube using update. This simple script moves an object forward every frame using transform.translate. Let's break it down. Here, vector 3.forward is a shorthand for the direction along the z-axis, moving the object forward in 3D space. Time, delta time ensures that the movement is frame rate independent. This means the object will move at the same speed, regardless of how fast or slow the game is running. Without time.delta time, the object's speed would depend on the frame rate, causing it to move faster on higher frame rates and slower on lower ones. Using time.delta time makes sure it moves the same distance each second, no matter what the frame rate is. So, every frame, the object will move forward at a constant speed, but the movement will be smooth and consistent across different devices and frame rates. Since update runs every frame, using time.delta time ensures that your object moves at a consistent speed, regardless of the frame rate. Late update function. Next, we have late update. This method runs after all update methods have completed for the frame. So, if you want something to happen after other updates, like moving a camera to follow a player, late update is the way to go. Here's an example of a camera script that follows a player using late update. In this code, the camera is following the player's position but with an offset. Let's break it down. Player.transform.position gives us the current position of the player object. New vector 3, 0, 5, minus 10 adds an offset to the camera's position, placing it 5 units above and 10 units behind the player along the Y and Z axes. This gives us that typical third-person camera view. But here's the key point: this script is inside late update. Why? Late update is called after all the update functions have finished. This means the player's movement has already been applied by the time the camera's position is updated, ensuring the camera always follows the player smoothly without any jitter or delay. By using late update here, we ensure that the camera moves after the player has moved, providing a smooth, stable following behavior, even if the player's position changes during update. Notice how the camera's position is updated after the player has moved in update. This ensures smooth and predictable camera movement, as it avoids any jitter caused by trying to move the camera before the player moves. Fixed update function. Finally, we have fixed update. Unlike update and late update, which run based on frame rate, fixed update runs at a fixed time interval, by default, every 0.02 seconds, or 50 times per second. This makes it ideal for physics-related calculations that should remain stable regardless of frame rate. For example, let's apply force to a rigid body using fixed update. In this code, we're applying a force upwards to the rigid body. Let's break it down. Vector 3.up represents a direction in the 3D world, pointing upwards along the y-axis. 10F is the magnitude of the force applied, so we're pushing the rigid body upwards with a force of 10 units. Now, notice that this is inside fixed update, not update. Fixed update runs at consistent, fixed intervals, which is perfect for physics calculations like applying forces. This ensures that the force is applied smoothly, regardless of the frame rate. If we used update instead, the force could be applied inconsistently, depending on how fast the game is running, which could lead to jittery or unpredictable physics behavior. By using fixed update, we ensure that our physics calculations are consistent and smooth. If you were to apply forces in update, you might experience jitter or instability due to frame rate fluctuations. Where to use each update function? Now that we've covered what each update function does, let's see them in action. Here's a practical example with 3 cubes in Unity, each with a rigid body component attached. The only difference between these cubes is which update function they're using to apply force. Each script below applies an upward force to the cubes. The only difference is the update method they use. On the left, we have a cube using the fixed update method. Here's the script. As you can see, we're applying an upward force to the rigid body inside the fixed update method. Since fixed update is called at a fixed interval, by default, 50 times per second, the movement of the cube is consistent and steady, regardless of the frame rate. Now, in the center, we have a cube using the update method. Here's the script for this cube. This script applies the same upward force in the update method. However, since update runs every frame, the cube moves much faster. Each frame might be happening more frequently than the fixed update time step, so the force is applied many more times per second, causing the cube to rise much faster. Finally, on the right, we have a cube using the LateUpdate method. Here's how the script looks. In this case, we're applying the same force as the other cubes, but the difference is that the script runs in LateUpdate, which is after all the update methods have been called. While this might not look any different visually from the update method, it's important to note that LateUpdate will execute after the player or object's movement has been processed in update. Now let's compare the behavior of these 3 cubes. Notice how the cube using fixed update moves at a constant and steady pace. The cube using update moves much faster because it's applying the force many more times per second. The cube using LateUpdate behaves similarly to the one using update, but the key difference is that LateUpdate occurs after all the other updates in the frame. So, what's the takeaway from this? Fixed update is perfect for physics calculations like applying forces to rigid body objects. It ensures that the physics remains stable, even if the frame rate fluctuates. Update is used for frame-dependent tasks, but you should avoid using it for physics. Applying force in update could cause inconsistent or jittery physics. LateUpdate is best when you need to do something after all the movements or animations have finished, like updating the camera position after the player has moved. Key differences. To summarize the key differences: update runs once per frame, ideal for regular game logic, input handling, and animations. Think of update as your go-to method for anything that changes every frame. LateUpdate runs after all update methods, perfect for camera systems or anything that needs to happen after other updates. LateUpdate when you need to make sure something happens after the game logic has been processed, like camera movement. Fixed update runs at consistent intervals, perfect for physics calculations and rigid body-based movement. Use fixed update for anything that involves physics or rigid body manipulation. Common mistakes to avoid. Now, let's talk about a few common mistakes beginners make with these methods. Mistake 1: Physics in update. One common mistake is using update for physics updates, like applying force to a rigid body. Since update is frame dependent, it can cause jittery or inconsistent behavior in your physics calculations. Using update here can cause problems when the frame rate fluctuates. Instead, use fixed update. Mistake 2: Camera movement in update. Another mistake is putting camera movement inside update. Doing this can cause the camera to jerk or stutter because it's updating before the player's movement has finished. Always use LateUpdate for smooth camera transitions. Best practices and final thoughts. So, what's the best way to use these update methods in your own projects? Here's a quick rule of thumb. Use update for tasks that happen every frame, like input and animations. Use late update when something needs to happen after all updates have been processed, like moving a camera. Use fixed update for anything involving physics, such as rigid body forces and collisions. And that's a wrap on understanding update, late update, and fixed update in Unity. I hope this video cleared up any confusion and gave you a better idea of when to use each method in your game development. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell so you never miss an update. And if you have any questions, drop them in the comments below. I'll be happy to help. Until next time, happy coding.